Welcome to this second episode of the APL Notation as a Tool
Wow.
of Thought.
We're on number 2 already. I can't believe it.
Yeah, podcast. We are recording on the 1st of November 2022. I'm Adam Botsevsky, and with me is Richard Park.
Hello.
And today we thought we would be discussing notation. Wow, look at that notation. But specifically notation that bothers us, problematic notation. So Iverson started off with something that was very close to traditional mathematics. It doesn't look like programming in the modern sense at all. It's all kinds of, firstly, it uses a proportional serif font in best mathematics style.
Do you have an example of this? Okay, it's the APL wiki page for Iverson Notation. Or you can see the System 360 fragment. But then I guess that's typed as well, so it's not quite the same.
Well, there's not a huge difference between typing it
no, there it is,
and putting it on a blackboard, really.
Is this shareable?
Sure.
I don't know what you're seeing now.
Yeah, no, I can see it.
But yeah. For the YouTube viewers, you can see this. For the listeners.
Yeah, but basically, it kind of looks like a mathematical algorithm. And it uses these arrows, which are actually branch points with conditions. It uses
the whole structure on the outside is pretty wild. For even a mathematical algorithmic description or something. There's not a lot of papers, I don't think, in maths that just like arrows flying between equations and things.
No, they will use probably bread text to describe that instead. But they do number their expressions, so
that's
they can
true.
refer
it's like step by step, yeah.
But this is specifically implementing algorithms, right? So that's why it's really a flowchart in a linearized form. So you could also put this as like a two-dimensional flowchart with little boxes, and then you compute this, and then you make the decision, and if yes or no, and you go to these two different places. This is all the same, actually. It's just combining all the decisions and all the computations into a linear form.
Yeah, I was going to say it's also pretty old. Well, yeah, say procedural is old school, but it's procedural for sure. Like
that's for sure. Yeah.
One thing that was interesting that this makes me think of was who commented on it? Maybe someone on the Discord with the competition winners presentation, and there they've got the examples of their code, and someone described it as the define then compose style, which is a more functional paradigm thing. And that's kind of a different way, right? It almost feels these days a bit, well, it's just a different sort of use of notation, right? Instead of procedural saying do this, then do this, then do this, it's like you define the procedures and then you chain them together as your kind of, instead of the flow being as these arrows like this, right? The flow comes as a result of the function composition.
Yeah, okay. Yeah, this is not functional programming.
No,
certainly
exactly.
Not in the modern sense. But then, okay, so the next step after this was, firstly, there were many versions of this. Things the spec changed over time. It was not very formal. And all these superscripts and subscripts are actually used, if I understand right, mostly for what you would use subscripting for in traditional mathematics. Although sometimes he also uses subscripts. If it's subscript on a variable, then yeah, it's indexing. If it's subscripting on a function or what eventually becomes a function, then it's an extra parameter for it. So I know he uses the like iota or the equivalence, and he uses, I think it is an iota actually, and he uses subscript 0 or 1 to set the index origin for that instance.
Oh my. Wow.
Yeah, and but you can also see a lot of things that did make it into the linearized form of APL, right? You've got the plus slash, you've got the or slash, reductions. You can even see encode and decode, although it looks slightly different than what you're used to. It looks like it's using monadic decode, and that's actually what he's doing. It's just that they didn't do that when they linearized APL into an actual programming
decode. Is that just
it's just 2?
It's just 2 base. Oh yeah, okay, fair enough.
Default is 2. That's all it does. which
Because
since he's describing
a
a
computer
computer,
system.
that
Yeah,
makes a lot
yeah.
of sense, right? So most of the time it's like that, and then it takes like the parameter on the left, which is how many bits it uses for it.
Mm.
So if I remember right, I think that's it.
Oh, and that does come across, right? Because that's the slight awkwardness with at least encode is like supplying the right number of places.
Yeah.
Whereas like if you do base power -1,
So that's basically what he's doing here, right? So whenever he's using monetic uh, decode, he doesn't specify how many bits it is because it's just all of them. But when he's doing monetic encode, he has to specify how many bits.
that's also true in current APLs, or at least
It is, yeah.
for decode you don't have to, because
But
it just
then,
becomes the single number in that base or whatever.
yeah, yeah. I mean, it would really be nice if encode didn't treat its left argument as a one
Yeah,
element
I was gonna
vector.
say
If
on the
it's
topic of
yeah,
notational annoyances, this is actually one that um,
it's
that I have the
one of the few times when I would be willing to make a breaking change. In code, it takes a number and it represented in some radix, which may be mixed radix of the left argument.
yeah. What's the classic example? You
I mean,
0, 24, 60, 60 or whatever,
yeah, 1,000 or something like that.
or
Okay, so yeah, so that's 1 hour
the number of
seconds. Yeah,
seconds in an hour,
right,
for example.
right. And but then
24, 60, 60 encode 3600. Yeah.
right, but you could also just do 60, 60, 60 here. So if you tried 60, 60, 60 encode 3600. And you can take away the zero. We don't need the leading zero here.
Oh yeah.
Okay, so 60, 60, 60 encode 3600. That gives us 100. Because you
That's
need 1 times 60 times 60 times 60 to get 3600. And here it would be nice if you could like auto size the left argument. So
no,
if you
just one.
just
Anyway, it doesn't matter. Just 1 times 60 times 60.
yeah, sorry, well 1 times 60 times 60. Yeah. Um, yes, of course.
So the
Um,
24 there is just for making it into days if you
yes,
had
yes.
enough of them. But anyway, it's not important to the point.
So basically, we're saying we want as many positions as necessary, and that would be nice if you could just write that as 60 encode 3600. But it treats it as a one-element vector, which means it chops it after any overflow just goes away.
Right. So if I just do 60, 60 encode 3600, I get 2 zeros.
And if you do a single 60, it treats it as a one-element vector. Really, it's the
Oh
same.
really? Oh, does it always return that? No?
Well,
What do you mean by treats it as?
well, no. So that's the thing. It essentially what it does is it gives you the modulus. If you do 3601, this will give you a 1.
Oh yeah, right.
So in
I'm
any
with you.
any sane person would use the vertical bar, the modulus, or remainder.
If you had the
If
single,
this is
yes.
what you wanted to do.
Yeah, yeah.
If on the other hand you wanted a single position representation with all overflow discarded, you would use a one element vector left argument. Right? So if you wanted to take the last this many bits of something, then you do it like that. But so there's really never a case for using scalar left argument to encode. Only one element vector, it would remain as it is, and scalar could be changed to do this. So
But say so. No, I don't. I don't think. I think every time I've used um, base inverse, so base power operator -1, um, almost all the time that I think I've done that is for the 2 case, which is funny.
yeah,
It's funny because that's exactly what's at line 4, I guess you'd call it, of this CPU description with the base only
that's
go at
because it's a
24
CPU
bits. I,
description.
I, I know, I know. It's just funny that that's now
Oh, that
thinking
that
about it
24
when
there is probably really significant actually. I think that's because the original IBM
the system
system
was 24-bit.
360 was 24-bit implementation. It was a 30-bit 32-bit system, but didn't actually implement the last few bits.
Oh, right.
It's just like today's computers. They're officially 64-bit computers, but internally they don't actually do that much. They do like 50 something because nobody will in the current state of affairs will need the last few addressable bits because you can't have enough RAM to need
All right.
64 bits. so there's no point in just wasting that. Anyway, so they linearized the notation. If you go back to APL Wiki and you go to APL 360,
Right. Is it linked from here? I'll
yeah,
search it.
you can just APL 360. Oh, okay, that will
Oh,
work.
oh, I was wondering if there was like a. It doesn't.
Backslash. And then if you scroll down almost to the very end, sorry, yeah, sorry. I
Oh,
jumped the gun here.
implementation.
Go to in the box on the right. You can go to a little bit up. This says documentation. So open up that.
This one here.
Yeah.
The APL
So now
360
we're
terminal
looking.
system.
Yes, that's the
On
paper by.
is this on J? Oh, sorry,
Stop.
J software. Yeah.
Yeah, it is. And then now scroll to the very end.
One of these things.
Yeah, one of the very last ones. Let's see. Go to figure. Yeah, to figures at the very end.
Oh, right, all the way down.
Yeah. So here are some examples of what APL 360 code would look like, and for the listener out there, then these lines that are drawn between these arrows drawn between code lines in original
And in the
notation,
right.
they've then been transformed to be these go-to arrows of today's APL. I mean, you can't use them today if you want to.
Yeah,
Not in
it's a right
default.
arrow that takes a line number.
Yeah.
And then it goes to that line number, and so you use, arithmetic or whatever array operations to compute the line number.
Mm-hmm.
And then I've seen some control sort of spouting out from this to go down the rabbit hole of not great avenues of notation in sort of APL as it develops. I've seen some paper, and I cannot remember the name or reference for it for the life of me right now, but it was describing I don't know what you call it, like a Boolean matrix-based schema for doing control flow in like a more complex application, because you can imagine this system getting spaghettified just very easily, turning into like you go to this or go to that or go to that. So what this person had done who wrote this paper had said, well, okay, what we're going to do is take a high level view of our application. We understand the control flow, what's supposed to happen, and we're going to make it more maintainable, more easily adjusted by defining all of our paths as Boolean vectors within a matrix, basically, in some way.
So then it would have some conditions and applying that with some kind of mask or something, or maybe in a product with a matrix, and that would compute where it needs to go next.
Exactly.
So you have essential branch selector rather than having it local everywhere.
Exactly. Yeah.
So you just go, okay, so go to the result of all these conditions applied with our control flow state.
I'll have a think if I can find it, and at some point put it as a link in a description somewhere. Whatever,
yeah,
but,
sure.
But I can't. But I thought that's cool and kind of clever, and but it shows patching an issue, over a deficiency. Exactly. Yeah.
I mean, the Iverson Notation originally was pretty cool. I think with those arrows, you could really follow that as a flow.
Right, in a procedural sense, but I mean, I don't know what the whole. I've not tried to implement a whole computer system, and I couldn't tell you how pleasant or unpleasant that actually is to.
I'm not sure what to do a modern day application with GUI and stuff, just drawing lines everywhere. Although, I mean, it would be pretty cool to maybe have an interface.
I guess there's scratches, right, and things like that.
Yeah.
It's people use to get people into it. It's very intuitive for people who aren't familiar with programming concepts at all. Say do this, then do this, and the arrows. We know what arrows are for. Like follow arrows and walk around a supermarket or whatever.
Although I think even this already has the kind of branching. If you look at the line, what is that, 11 or something like that, in the example of Iverson Notation.
This one here, go to 12, 14, 13, 17,
19.
Sub 19, all parenthesized, then subscript N2.
Subscript N, subscript 2.
Sorry, yes. Second element of N? I don't
Yeah,
know.
I think so. And then it uses that to select one of 5 lines to go to. So this is, I mean, and there are a few other examples here. You can have a subscript to a superscript and things like that. And it gets a bit ridiculous. And so they if you go back to the 360 examples in there, so then they linearized everything. So they use these square brackets for indexing, which is like subscripting. And they also introduced what this notation for vectors, literal vectors. This is something that came up in the last episode of the Raycast.
There was a stranding.
Well, today we might call it stranding.
Back then it
Um,
was just, well, well, maybe not called anything. You just write
it's
some
just
numbers next to
vector
each other,
notation, right?
and it becomes a vector.
But only that. So if you look at this famous expression for Pascal's triangle, and there he's concatenating. No, that's actually it's a vector, so that doesn't apply. But nowhere will you find two variables that both hold
Oh, an array,
an array, yeah,
greater
a
than a
scalar.
scalar, a
No,
non-scale.
even a scalar.
Oh, right.
You couldn't have two scalars, both of them, and then
So this at the time this was just literal numbers and
yes,
characters, maybe?
not even characters. The only
Just
way to
literal,
put
just
adjacent
numbers.
characters would be in quotes. You couldn't
Ah,
do the quote A quote space quote B quote like you can today. There was no nested arrays. There was no clash for these and with operands like we have today, because the only operators that existed were inner and outer product,
and then
and
reductions.
reduction, and then scan came soon after that.
Okay.
You can see here, I don't think it has scan here, just inner and outer product and other array
Yeah,
operations.
now I know it's controversial about stranding, which is what we're going to go on to the problems of it just now, I think a bit more. But I really like being able to write numbers, number, and that's a list of numbers.
Yeah, it's so much. I mean, you're not alone in that. I also kind of like it. But you're definitely not alone. Stephen Taylor even defined it as an indicator, or maybe even a requirement for an Iversonian language,
Oh,
or an array,
really?
or even or an array language. I don't remember, some one of those.
Can't be
That
that,
you have
but yeah.
this notation, right?
To be able to just write numbers separated by spaces, opposed to like every other, language that isn't really an array language, where typically you'll do looping constructs or some kind of iteration explicitly, and then when you're defining them literally, it's some kind of parenthesization or bracketing, and then commas usually between all the values.
But that's not the case in Lisp, is it?
Actually, no, you might be right there.
They just put spaces in between. So, and this wasn't really an issue either. There was never
Yes.
any issues with this. It would just work. There wasn't even an issue with binding strength if you would index directly into such a vector. So if
And you're
you
saying you couldn't strand named arrays. So you
named or
didn't
parenthesized or anything,
so you didn't really even have the ambiguity of parsing something, right? If you saw numbers name numbers or whatever, then you
then
know that that's functions applied to
yes,
values.
yes.
Yeah.
Not even operators, because there weren't any user-defined operators.
Yeah.
Only functions. So everything is immediately parsable.
Yeah.
Sometimes I long for the good old days when everything was everything was so simple.
Take me back.
And yeah, so and there was
Well,
no
people do long for. I mean, that's why people try things. They're trying to develop
the,
different ways of
yeah.
expressing it, right? Because the evolution has ended up with these little rough edges that we're going to show, I guess.
Yeah, and then there wasn't also for a newcomer, there's no real doubt as to what syntactic role did any particular symbol have. You
Yeah,
had the right and left arrows. Okay, that's go to an assignment. You have square brackets for indexing. Then you
yeah,
just need to know that slash and dot are special, possibly a
right.
backslash, right?
Yeah,
And that's it. There were all other symbols are going to be functions,
yep,
and the valence can immediately be inferred by adjacent names. Actually, oh, no, that's not even true. No. If you had A, B, C after each other, then B must be a function, but A could also be a function. or an array. You don't know.
Oh, okay, yeah, fair enough. But
If you don't have a naming scheme.
right, it's not as good as we thought. But
Okay, but there are
still,
only two possibilities, right?
yeah.
Whereas in today's world, I don't even want to enumerate the number of parsing possibilities for ABC. It's, um, and that's just in APL. In J, it's even worse.
Right.
Just the J tacit forms, like there are almost no syntax errors left. Everything means something.
Yeah, there's lots of things in J that I don't really know about. So what,
So if you take something like this, like if you go into an APL session and
hmm
then um take some numbers, like digits of pi or something like that.
hmm 3 space 1 space 4 1 5 9.
Yeah, that's fine.
That'll do.
And then put square bracket after that.
hmm Oops.
It's
Square
fine.
bracket.
Yeah, and then so we're choosing the nth digit of pi. So
Yeah.
let's say we're choosing the third digit, which would
Oh,
be a
I thought I had
4.
numlock on, but I didn't. There we go. So yes,
Okay,
the third digit of pi is
it's
4.
4.
Wow.
Okay. Yeah, that's fine.
hmm
And everything was fine until basically APL2 and nested arrays and strands.
Yeah.
Okay. And then and the generalized operators and whatever not. And then everything just goes downhill from there.
Not just like, yeah, notationally, well, it's kind of what we're focusing on, but this is the major schism of APL vendors and implementers, right?
hmm
Is deciding how should an array that contains any other type of array, how should that behave?
But it's not just behavior of it, but also the syntax. Right?
Yes, yeah.
Iverson and IP Sharp's APL, Sharp APL, and therefore J,
Hmm.
they never added the generalized stranding, so they still had this vector notation, and
Oh,
it could occasionally clash, but much rarer. So a classic one is you could do it like with power, right? So if you do like one drop power 3
yeah.
on the digits of pi, so you can on
The 141.
yeah. So now we have one drop power operator 3 3 1 4 1 5. Why 3 3? Because the first three is the operand to the power operator, and then the
Yeah.
next three is just part of the argument. And even in J, where you don't have generalized stranding, that would clash.
Okay.
And so in APL2, actually, they decided that operators bind stronger than this vector notation.
So
So this
so
would
you would
work.
get, so the 3 would bind to the power.
Yes.
But so this is cool for power because it when it takes an array, it's a single number, which is a number of times it's going to run the function, right?
Yes.
But for for example, rank, that is a vector, or it can be a
It
vector.
can be a vector, but how often do you actually use a vector? Often you can
Well,
find a negative value that will do what you want.
yeah, yeah, I get that. I mean, it's more in terms of, so are there array languages APLs where you don't need any kind of other than a space separator between?
Well, the problem is in APL2, if you were to use the rank operator, then you must parenthesize the right operand.
Yeah, or the whole thing.
The whole right operand, because otherwise the operator will break the operand.
Not even just parenthesize the function operator operand,
No,
array
no,
operand expression.
because it will apply.
Uh,
Right? So you have function dyadic operator digit space digit or number space number. And that will not work. Even if you parenthesize that entity, they will not work because it will take the first number from that list of numbers and then make a derived function and then apply it to the rest of the numbers. This might seem very foreign to you because you used the dialog APL, but
well,
for an APL,
I'm thinking, so do you have to double parenthesize in that case?
no, that's it. Now you don't need to parenthesize anymore.
Oh, right. No, what I've written here, which is one down arrow, power diaresis thing, star diaresis,
Yeah.
left paren, 3 space 5 right paren, and then the values that I want to apply to. Even though
Yeah.
this is a nonsense expression, but that's not. We're talking about just the
Well,
syntax of the thing. Now, me personally, wait, is there more story to like the evolution of this, or talk, or
well,
should we
there's a little,
show?
little bit more. If you, what happens if, so if you go back to the example that you had before with digits of pi, 314, you can stay here in the APL. Three
Oh,
one
sorry.
four one five
Oh, with
nine,
the
and then that. Now
indexing.
and then yeah, square bracket 3, and that selects the 4. But after that square bracket, what
Mm-hmm.
happens if you write another list of numbers like 2, 7, 1, 8, whatever? Okay, so now
Uh-huh.
clearly, so now what we have now is an index expression in the middle between two literal vector notation things.
Mm-hmm.
And the indexing goes obviously on the vector on the left, or
Mm-hmm.
the array on the left.
Mm-hmm.
But what's stronger? The internal binding in the vector notation, or the square bracket indexing to its immediate left?
So the alternative interpretation I'm hearing here is we've got, some numbers and then left square bracket 3, right square bracket, and then a list of numbers on the right. And then the alternative is that it's 9 indexed by 3.
Yeah, so in
And
APL,
then that becomes a single unit. So the
yeah.
scalar 9 indexed by 3, which is an error, but let's ignore that for now. And then that becomes its own individual entity in the middle of this whole stranding expression.
Yeah, so
I
surely
can parenthesize that to make
that
it.
would make no sense in APL 360, because the only thing you could ever have, the only element you could ever have to the immediate left of an indexing would be a simple number. Right? There were no other strands. There were no nested arrays. There would be nothing in the last element before the square bracket that you could index into.
Hmm.
And you couldn't even do the choose indexing thing. You can make this not be an error by doing enclose Zilda instead of 3.
Yes, I see. Yeah.
Mm.
And then so with parentheses. So this is
Yeah, this is
31415, and
9
then
in,
this 9 indexed by
in
enclosed empty numeric vector
yeah,
2718.
yeah.
And obviously, so 9 indexed with that returns the scalar itself. But then if I get rid of my parentheses, well, okay, the issue there
Oh,
is that we're not
this is a
is how it actually is in dialogue, yeah, not how
no,
not the hypothetical
no, and this is
strong
fine.
binding
So
of
this is
indexing.
choose or reach indexing really.
Hmm.
So this is saying, okay, we are going to select from the outer dimensions, and uh, we're going to step 0 dimensions into the array, returning a scalar result like this. The first element is 0 steps into the array. That's the entire array. So we're returning a scalarized entire array.
Mm.
So then we get an enclosed 314159, and then the next elements after that are 2718. So in all in total, it's 5-element result. In APL2,
Mm.
the indexing is stronger than internal binding in the vector notation. So here, yeah,
You
it's
would get, so in APL2 you'd get this one above where I've
yes,
parenthesized it.
without and if you want parentheses, if you want to index into the entire strand on the left, then you
You have
need
to
to
parenthesize
parenthesize that
that.
strand, which means that APL2 was not backwards compatible with APL 1 or whatever, original APL 360. Dialogues developers were too scared of making such a breaking change, so they stuck with the old. They decided that the binding strength in the vector notation is stronger
Stronger.
than
Mm.
indexing, even though that's often not really what you want. But yeah, because that means if you put multiple vectors and each one immediately followed by their
Yeah.
own square bracket,
And when you
the
first learn and you because when you first learn APL, typically using square bracket indexing the most.
yeah,
Um, and you might do that where you're saying, I've got some array, usually it's named or something, and I want the third one of those. And then next to that, I've got some other array, and I want the fifth one of those. but you want those values then put together. And then you do that, and you get some weird. Well, I mean, they can all necessarily weird, but
so in this case, actually, you can do that. You can make this work. So define an array to be whatever the alphabet, because
yeah, right.
Okay, and then change the 5 to a 2 instead. Okay, so now we've got 3, 2, 1, 4, index 3, array index 2, where array is the alphabet.
Yeah.
And the result, can you predict it?
Oh, sorry.
Okay, it's okay.
I mean, yes.
Or explain it at this point. So the result is the enclosed alphabet.
Yes.
And the reason for that is that the leftmost square bracket picks out the 1 from 3, 2, 1, 4. So we pick out the 1. Then we strand that with array. So we have a 2-element vector, which is a 1 followed by the alphabet. And then we take the second element of that, which is the alphabet, as a scalar.
Right, exactly. So it's
and to fix this,
the rightmost indexing is taking weirdly everything on the left.
Exactly, which is really weird, but that's consistent with APL 360. If you don't want that, you have to parenthesize the right half of the expression. So you have to parenthesize array square bracket 2.
Right, or what you end up kind of brute forcing as a new user, which is just let's parenthesize everything.
This really shows that I mean, stranding being what it is, square bracket indexing is even more problematic than than otherwise. It's problematic,
but again, it's without this thing. Stranding. So, what I'm seeing is the through line of these two. I mean, these are things from, like we said, like OG APL, APL 360, that are then have been Dialog at least, and other APL vendors have tried to maintain or incorporate along with the extensions in a backwards compatible way. But the original feeling of using these is great. Numbers separated by spaces, that's a list of numbers, awesome. Just stick a square bracket with another array inside it to do indexing, and that's also awesome. And it's just this, well, like you said, the advent of nested arrays, the arrays inside arrays, and trying to make the behavior consistent.
We should have just stayed flat. Should have stayed with non-nested arrays. So I mean, yeah, I think the square bracket indexing has outlived itself, although we don't have a good replacement. In a future episode, we'll discuss primitives that we want. Yeah,
that's right.
The indexer.
Where have I? Whatever. I don't know where I've put my. If that's that. Yeah, that should be Control Shift. Never mind. Different keyboard.
X, Control Shift or Alt Shift X.
Alt Shift X. Oh right. Yeah, my caps lock thing wasn't doing it. Weirdly. Anyway, yeah. We'll talk about primitives, what we want in another episode. But yeah, a selecting function to be consistent with all of the other, even though we have that, but it's also awkward.
Yeah, that wouldn't work well with the multiple. We'll get back to that another episode. Let's not get ahead of ourselves. So, but as you said, most of the time, what you want is just a single number right operand to an operator. You can actually have a problem with that. You ever experienced having the left operand being a problem?
Like with at? No, what else?
It's very rare, but it can happen.
Most of the time I'm using the function left operand.
We can construct an example. If you if you say two bind plus comma a top comma, sorry. Okay, so we can parenthesize this and give it left arguments 1 and 3 or something like that. And okay, yeah, sure, and some other number on the right, yeah. Okay, all right. So what we have here is 1, 3 open paren, 2 jut plus a top comma close paren 5 spelled out so people can type along at home.
2 jut plus, so it's increment by 2 or increase by 2. A top concatenate.
Yeah.
So we'll do a concatenation of left and right arguments.
You can remove the jot and the jot diaresis here, make it a train. It's an
And since we're
AGH.
parenthesizing it, yeah,
Yeah.
then it is 2 plus comma.
Okay. Yeah. However, since it's just a derived function, right? 2 bind plus a top comma, then you can just remove the parenthesis, right?
Yes.
No, you can't.
Because the stranding binds
Stranding just hit
132
yeah,
now.
jot plus, right? And now it just means 132 is the left argument to plus a top comma. So it's saying 132 plus 5 comma
But now,
5.
because we've bound the left argument of the whole derived thing,
Yeah.
we've now got a monadic comma. It's just raveling 5 before.
Which really should be a length error, but we're lenient and allow it as a one element thing.
Yep.
It would be better maybe to have more numbers on the right, but it doesn't matter. Right. So here you have stranding biting you on the left. It can happen there too.
Mm.
And so it's not just the rank operator, but it's often the rank operator.
Yeah.
And
Because that's the one where you're quite often putting in literal numbers as your like, and it's perfectly okay to do this.
well, even
have,
if it was named, it wouldn't work, right?
right, times rank 1, 2, 5 by 3 reshape. I don't know, doesn't matter. Random numbers.
Yep.
Even if it was named. Oh yes, yeah. True.
Right. So you have a vector times rank 1 to a matrix with that number of columns.
Yes.
You don't need the parentheses at all here because you used a random
because I used the function. Yeah, well, okay.
but it's so confusing, right? So people end up writing right tech as if it's part of the syntax, which is kind of funny.
Well, that's because they see it a lot. See, me personally,
Yeah.
I actually these days I prefer to parenthesize my
Your rank expressions.
Rank expressions, and then even something like we've seen above here with the. I mean, this one's lucky. Your 2 plus concatenate example happens to come out as a nice 3 train that I think
it didn't have to be. Right?
No. So that's just a coincidence. But yeah, in general, so do I do it with at? Maybe less so because if you've got a function there. But okay, definitely my rank expressions. I'll almost always be parenthesizing these days rather than using right tack myself.
Okay.
Because then visually I get this like the unit, right?
So
and
rank
trains as well.
The rank operator is a more generally applicable construct than using the bracket axis, because you could use bracket axis as well. You know about that?
Yeah.
So you can do 1 0 what you're 1 0 -1 times axis,
the second axis in this case, because now we're matching. We care about the largest rank array in our expression. It's the matrix. So
we want to take this vector and apply it along its second dimension, something like that.
For this I find this one slightly, or maybe it's because I'm not used to it, but weirder to explain verbally, especially when it's like,
it's not just verbally. It's like I can barely.
Because you're like, okay, so there's the second dimension of the matrix is the rows, sure, but it's the second dimension of the, I guess in the same way that if you do rank with the higher rank, it's just encompassing the whole thing. So the second dimension of the vector, it's only got one dimension, that's its length.
So what happens if you have a matrix on the left and a 3-dimensional array on the right? Can you reason about it now?
Well, okay, so I guess we've got to make sure the frames match or whatever.
One easy way is just make them square.
True, but then I don't feel like I'll understand it as much because I'll just be stabbing.
Okay, so you want to do a rank 2. Let's just say a rank 2, right? So now we have a matrix on the left, and then you can just do 2, 5, 3, reshape 9 on the right. So 3, 5, 5, 3, reshape 1, 0, -1 on the left, and 2, 3, 5, reshape 9 on the right. And we want to do, I mean, I can reason
rows. We're still trying to multiply the rows essentially, right? Well, no, I guess it's the 5 by 3 matrix on the left.
Let's just do it with rank first to see what the result is.
Okay, yeah, well, at least with rank I can understand what we might be going for, which is, the shape on the left 5, 3 is the rank 2
We still want something that's 253.
And then it matches the two matrices that consist of 3D array on the right.
There's a little bit dangerous because the duplication on the left is not the same. It could mask an issue.
Oh, you mean the fact so that
yeah, maybe do 1 -1, 1 0 -1, and then 2 0 -2 or something like that.
Yeah, okay.
So let's have a look at what this, and instead of 9, maybe do iota 30 or something like that. So we can. Okay.
Yeah, so we're gonna have the numbers from 1 to 30 across 2 planes with each 5 rows and 3 columns. And then we got some like positive and negative and 0 multipliers on the left that will form a fairly regular but jilted enough pattern that we can recognize the shape.
This looks sane to me.
Yeah.
Okay, so doing this with bracket x's.
But that's because, so with rank operator, you're framing things. I mean, this is where the notation of rank operators is maybe awkward because of the stranding, but at least the mental model and conception of like rank k subarrays, these cells that consist, and matching up the cells. I guess once you're used to it, like I am, then it feels fairly regular. And then I struggle, what we're going to talk about just now, going back to the axis model of these arrays. So what we're trying to do a similar thing, but matching which axes with which axes, or which axis. It's the rows in our matrix on the left.
I think the traditional method is just try everything and see what works.
I mean, technically rows. My intuition or my feeling is to say rows, which now that we've upped the dimensionality,
that can be because that
is the third dimension.
Because we don't have a vector. We don't want to apply vectors on the rows. We want to apply matrices on. So I think a 2 is the right thing. Is my guess.
Well, no, because 2 is the column. Oh, because you're saying we've got 3 columns in each. Oh, yeah. So that's the other thing. You kind of have to transpose your thinking a little bit.
I'm not confident here.
Because you're like, I want to multiply rows of rows, so therefore we match the columns because they're the number of columns.
That's definitely that wasn't right. Does 3 work? Does 1 work?
I don't think any of these will work.
Can you do 2 of them? Like 2, 3?
Only thing I've used multiple with in the past is
Ravel.
Ravel. Have I ever used concatenate? I'm not sure. Oh, okay. It is 2, 3.
It's 2, 3 because you want both the rows and the columns, but not the layers.
Okay. So this is my deficit really in understanding. This is because I can do it with rank, so I do it with rank. But
okay,
that does make sense, and that does make sense in that model of thinking. You're saying, yeah.
Imagine if the rank operator symbol. Okay, so forget that we had this bracket axis for a moment. Imagine if rank operator was spelled left square bracket.
Yeah. Okay.
And the right tech was spelled right square bracket, which actually it is in J, so it's not like that far-fetched. So it would look like this kind of syntax.
Where's NG and APL? You can actually do that. You can do.
I don't think you can do that in NG and APL.
I know you can assign symbols.
No, but you can assign symbols, but you can't change the syntactic meaning of things. I think. Yeah, you can't assign to a syntax.
Oh, square brackets is not a.
But maybe we can do it with some square bracket lookalike.
Or like letters that look like L.
No, you don't even need to do that, but just a letter that they're always used like square brackets and things that are. Okay, let me share.
Oh, you mean in Unicode? Like,
yeah, because it allows sharing to
NG and
anything.
APL, yeah.
So, okay, so we have this, That's not really very clear because it's not like a nice symbol or anything. But that kind of looks like a square bracket.
Yeah, okay.
So if are we
So we
allowed
can
to
do left
value error?
Oh, can you not assign operators or something? There's probably way more limitations in that we don't.
I
No
don't know.
one uses.
Oh, hold on. Do I need to like this or something?
Oh, it's not alpha alpha. It's alpha underbar.
I think it's both.
I don't
Syntax
know.
error. Am I allowed to? Does it
But
even have?
I mean, try assigning that symbol
Hold
to
on. It
just
doesn't.
like
It doesn't
a
have
variable.
rank. It doesn't have rank.
Oh,
It doesn't know what that means at all.
never mind. But I think, yeah, so I'm thinking, right, in terms of, or is the
But
other,
it could work,
is
right?
another way better, right? I mean, these are really nitpicky details in terms of usable notation, especially for things like here where we're talking about what ultimately manifests as what magic numbers. You should try to avoid those, or the negative ones are slightly less magic, I guess, because they
Oh,
at
we can
least
do.
relate to relative ranks.
Yeah,
Or
let's just try it with power. Does that work? Ah, procedure. Okay. All right, it returns procedure, so that's fine. So we two drop 3, 4, 5, 6, 7. That's fine. And then
and you need right tech to be the other
power
bracket.
3, right?
Hmm
Why did that not print? Oh, of
Dead.
course. There there aren't enough elements. Okay.
Oh, right.
Okay, so now we want the other bracket. So I love shape catcher. It's like the best thing since sliced bread.
Yeah. Have we got sliced bread in Unicode? Let's find out.
You should have found a better bracket than that. Whew. I mean, I think it ran.
Yeah, I mean, there you go. So do drop 5 times.
So this is. I mean, it's deceiving, right? Because it looks like it's one syntax, but it's actually not. It's really it's really another syntax. But if it had been that, and so that's where I thought about that. Um, what if we went totally out of the box for this kind of syntax?
Okay.
So it's especially rank. So the few times when you need an operand like that clashes, okay, but it's the rank operator is so central to everything we do, right? It's so fundamental. And so I was thinking, what if we could instead of say rank 0, 1, so we can do things like 1, 1, 2, 3 plus
Paired with the
rank
rows.
0, run. Right? Obviously, this won't work in GNAPL, but just for the sake of it.
Yeah,
3, 4 reshape iota 12, right? So
yeah. Yep, yep.
in dialog APL,
Yeah, so each scalar number,
this this
the
will,
1 added to the first row, the 2 added to the second row, the 3 added to the third row.
yeah, maybe a
And
better
because of,
example
well,
is
on top of this, we've got scalar extension conveniently.
yeah, but that's yeah, that's fine. And
And
so now,
there's an argument as well. Actually, this came up sort of vaguely in our last little chat about Yorick and stuff, is that if it had leading access, you wouldn't even need this
right.
leading access agreement. You could just say plus, and it's like 3 things on the left, 3 things on the right. Oh, let's just stick them together if we can.
Yeah. In J, we can bring up J. Why not? We're allowed
Yeah,
to
because in
breathe.
essence we're yeah, in essence here we're defining loops, right, with the rank operator. And it would be nice in some cases to not have to do that. And that would be a nice notational boon.
So you can do 100, 200, 300 plus 3, 4
Dollar.
reshape iota 12.
Right.
Right, so that
Boom.
just works. But you can also do it with rank 0, 1, right bracket.
Yeah, that's right. Right bracket is right tack, eh?
It is.
Yeah.
So I always forget this thing about the editing works differently here. But still, I mean, sometimes you do clash. Like here in J, even though J only has these vectors notation, it doesn't have general strand notation. In this case, you have to have the separator. I mean, you can parenthesize, but you have to have the separator.
Yeah.
BQN doesn't because it doesn't have this vector notation. But as you say, the vector notation is kind of nice.
It's funny actually. I don't know if I'd parenthesize in J because all the other stuff looks more angular. So maybe the square bracket fits in more visually. I don't know why I feel
it
that way
really messes
with
with
the
my
dots.
head.
Whereas with APL, the squiggles are more sort of curvy and rounded, especially the APL 385 font. I think
It's true. You can
adds
use,
to that.
but it messes with my head that brackets and braces are not paired things
Yeah,
in J.
I find that odd.
This is just weird. Um, but perfectly normal. So
Right, but so where are we
imagine if
going off the yeah, you had
so
a radical
imagine
idea.
imagine if we could write this as something like this.
Oh, your superscripts.
The font doesn't look great here,
That's
but
a
let's
shame,
just
isn't it?
I can fix that, I think. 1 second.
So, yeah, one thing I thought when we used to chat about like new APL stuff, or if you wanted to redesign or whatever, was like I'm adamant that you must be able to handwrite the stuff. So I think
That didn't go in much better.
1,
Anyway,
2, 3 plus scalars vectors. What do you call it? 3, 4.
it's horrible.
Reshape iota 12
Wait, I'm not.
versus what? Plus rank 0, 1.
Wait, what are you? Yeah,
Just
okay.
thinking about
So
writing things because I find that
this is pretty neat, right? I think.
the superscript one.
Yeah. Or you can, if you want to keep writing. So this is 1, 2, 3
not
plus
on the
superscript.
left, one on the right. We go like tensor notation
Oh,
esque with it.
that's actually no, but that doesn't. Yeah, okay, that could work.
Although I
was
guess
thinking.
now let's go better with it. Naught on the left,
Yeah, exactly.
1 on the right.
Yeah, that makes more sense. Then you always, otherwise, which one is which?
Yeah.
So 1, 2, 3 superscript 0 plus superscript 1, 3, 4 reshape and iota 12, right? The problem is, of course, sometimes you want multiple rank specifications after each other. If they're adjacent, you wouldn't know. Oh, I guess
We keep
no,
going up.
no. There's no problem because I was thinking that sometimes you need a vector, right?
So we're thinking like
But you never
plus
need
rank
one.
0, 1, rank 1. Which I've written horribly there. Let's make the 0 bigger. And that's also horrible because my 1s look like vertical bars. So I need to fix my handwriting before I can do this.
So if you had adjacent specifications, they would blur together. But if you only ever have one number, then you would say there isn't stranding for the superscript.
Oh, right.
Then you could have them adjacent to each other. You just need a space, so because you could have 2-digit ranks if you're crazy and you're using arrays of more than 9 dimensions. then you could have but in that case you need a space in between them. But that's probably a good idea anyway.
Wait, so we're doing. So how am I expressing this multiple loop here?
So this is
Currently we've got the 0, 1 innermost.
Yeah, so you
loop, and then where's my 1, 1 go?
So then so
they go outside the others?
It. Yeah, parenthesize it.
Parenthesize what, the whole thing?
Yeah, parenthesize that.
This.
Yeah.
Oh, and then put 1, 1 above it there.
Yeah.
And then all the way up.
Mm-hmm.
Okay,
it's very
not
rare.
Awful.
Well, it's even shorter than what you otherwise have. You anyway have to use.
Well, yeah, but that's because we're going in the second dimension. You can do all kinds of stuff once you decide you don't need to be linearized.
We don't.
And then blessed poor JD, who's just done all that work to do the token, the inline, piece by piece debugging individual lines of APL, has now got to make a 2-dimensional debugging interface. Like, what's that?
I mean, this brings us back to the beginning, right? Iverson Notation was inlined to
make it work with computers.
Yeah, it was mostly because of a technical constraint. But today, there's really no reason why you can't do at least two-dimensional writing is
Yeah,
not problematic, and
once we're into VR and we're like doing
then can do three-dimensional. But no, but
3D code debugging.
what's it called? Wolfram Alpha recently added two-dimensional input,
All right.
and graphical calculators have done two-dimensional input for a long time. I've seen both Casio and Texas Instruments and Hewlett-Packard graphing calculators in high school.
That's not just superscripts as a font choice. This is actual.
No, you would do division and it would give you like two boxes
Oh, a
on
thing
top
on
of each
top.
other.
That's right. Yeah, no,
Yeah.
we used to. Yeah, I've got a calculator that does that. Yeah.
Yeah, and I don't even think the input was very awkward. Like you use the arrow keys, you just navigate around. If you do insert formula in Microsoft Word, you can also use the arrow keys to navigate around these little dotted boxes.
So we're
and
gonna
fill in.
do so. You know, I'm just gonna get rid of this.
When I was
Put 'em
little, I
here.
was always thinking, why don't the operators take their operands like on top and below themselves?
So we've got the dialogue under the APL classic train of the mean plus slash divided by tally.
Yeah.
And now we're gonna do, and you can apply this rank. You can say, you know, let's take the average of every row on my matrix. I got to go in a second, but let's do this just for lols. So now we're doing plus slash over the tally. Applied
Oh yeah, like
rank
that.
one. Applied rank one up there.
You probably need a parenthesis there.
So maybe over the whole.
Yeah, that's no worse than in mathematics when you have like power over a fraction. You need parentheses.
So then literally sum over the tally, applied rank one with a little thing like that. Honestly, I'm so torn as to whether I don't know if I'm just so, you know, used to the linearized form and having a predisposition to thinking, okay, that's obviously going to be usable in my system that I'm comfortable with, versus this, which is more compact and stuff, but I actually have no idea how pleasant it is to use in real life to express things with.
I once showed this idea I had when I was little, that the operands should go vertically with arguments horizontally.
Okay.
And in a three train, the middle tine actually acts as a dyadic operator. Remember
Yeah.
the history for that. Iverson there was a while when he had these over bars on top of every scalar function, so that it was the operator equivalent. So you would have like you would write the same train as
We
division
really need-
over bar.
We need a train that's less mathematically inclined.
That's fine. So
to do
no,
that
no,
with.
but the division is really nice because the way I was reading this is division. So you have division. You wrote it as division as a line, but you could write division as the symbol with the two dots, even though
Yes,
some
yeah.
people say you shouldn't use that. And then you have plus slash on top of that, and you have
Yeah.
this tally below it.
Oh, but the
and they're
operator
saying
of the slash.
the division acts as an operator, taking two operands. One is on top and one is on the bottom.
Yes.
That actually comes out really nicely
In this case.
in this case. But
That's why I wanted to take it to another less.
yeah, so you could have
In this case,
unequal and on the top, and right tack on the bottom, and partition
in the middle.
middle.
We're just verticalized this. Not great.
I mean, yeah.
I mean, ignore my absolutely atrocious not equal there. That makes it frankly difficult to see what's going on.
It's fine.
Less convinced. Well,
No, but
I guess just because division has this thing.
Yeah, the problem I came up with though, as I thought about this, was but any of the operands themselves could be a derived function. Now what?
Yeah. Well, I already thought that when you said about putting the
exactly
this slash, is that supposed to go below the plus really, and it just becomes like a long.
And so I think we can finish on this note. We've identified a deficiency here. Is our world is sadly limited to 3 spatial dimensions. I mean, I want n-dimensional paper that I can write my expression on. It would be awesome.
Would it? I mean, yeah, I guess it's the whole eyes projected onto a flat sort of mental image in the brain is also a limitation in terms of like how you learn and practice visualizing things in your head, because the concepts don't appear that way. necessarily. A lot of people a lot of people have strong like visual or verbal or whatever internal representations of like when they do thoughts and thinking, but it's not exclusively like that. Sometimes the weirdest times is definitely when just like you have the thought, it's in your head, but it's not manifested in a like linguistic form, expressible, and you have to work to get the thought to come out, even whether you're writing it or speaking it or drawing it.
Yeah, but if you're seeing it as like
concepts don't work like that, I don't think.
I don't know. I have to try it. Give me a dimensional paper. I'll try it. I'll get back to you.
Let's figure it out. Right. Anyway, yeah. Let's
finish on this note then.
Yeah, leave it on that.
Okay. Thank you for joining in to the attendees here, and we'll get back probably to more of this notational stuff and primitives that we need to.
This does make me want to go crazy with this though. How far can we?
Yeah, go have lunch instead.
Yeah. All right.
See you
in a bit. Bye.